North Antelope Rochelle Mine in the great state of Wyoming. The bitter, frozen January of the year 2000. The air temperature down on the deep floor of the massive Powder River Basin is a bone-chilling 10 degrees below zero. A gigantic 400-ton Caterpillar 797 haul truck slowly backs into the active loading area, its massive, rumbling diesel engine loudly echoing against the towering, sheer rock high wall. The primary, building-sized electric rope shovel officially assigned to dig this specific bench is unfortunately down hard for an unexpected emergency steel cable replacement. In previous, slower decades, a broken-down primary shovel meant the massive haul trucks simply parked, engines died, and total mine production ground to a complete, expensive halt. But today, the stress dispatcher absolutely does not stop the fleet. Instead, a gigantic, 260-ton rubber-tired front-end loader rolls aggressively toward the blasted, jagged coal face to directly take the massive shovel's place. This is the legendary LeTourneau L-2350. It is absolutely not a secondary, auxiliary cleanup machine. It is a primary, heavy-duty production loader, designed specifically and intentionally to match the sheer, overwhelming scale of the new ultra-class haul trucks. The veteran operator drops the massive 53-cubic-yard heavy steel bucket flat to the frozen pit floor and accelerates the giant machine directly into the towering wall of fractured coal. When a traditional, older mechanical drive loader pushes heavily into a hard bank, the massive torque converter mechanically multiplies the engine power, but the tires inevitably, violently break traction. Spinning a 12-foot-tall, incredibly expensive rubber tire against sharp, shattered, frozen coal instantly shreds the heavy rubber tread. But the LeTourneau L-2350 absolutely does not spin its tires. It crowds the hard bank with a silent, terrifying, continuous force, burying the massive bucket all the way to the heavy steel pivot pins and cleanly ripping 80 tons of coal straight from the seam in a single, perfectly fluid upward arc. The traction is absolute. How in the world did a rubber-tired machine weighing 260 tons physically push into a solid, unyielding wall of earth without instantly destroying its own tires in the violent process? The LeTourneau L-2350 carried an incredible official payload rating of 160,000 pounds, or 80 tons. A machine attempting to forcefully drive that much massive weight into a hard bank of unblasted or poorly fragmented coal faced a highly critical physics problem: the dangerous gap between available engine torque and available tire traction. Older mechanical loaders relied heavily on slipping clutches and heavy, fluid-filled torque converters to manually modulate power, but the human operator ultimately had to guess the absolute friction limit of the tires purely through the shaking steering column. Brilliant LeTourneau engineers discarded the traditional heavy mechanical transmission entirely. Instead, the massive 2,300 horsepower diesel engine directly powered an enormous generator which sent raw electrical current straight to highly independent electric motors, securely mounted inside all four wheel hubs. This innovative electric drive system utilized a highly advanced, computerized traction control algorithm. The onboard computer constantly monitored the precise rotational speed and physical resistance of each individual wheel thousands of times per single second. If the digital system detected that a single tire was just about to lose physical grip and spin against the sharp coal, it instantly, automatically reduced the electrical current strictly to that specific motor, perfectly shifting the massive torque directly to the wheels that still possessed solid, reliable traction. Before we go any further, if this specific kind of content is what you have been desperately looking for, subscribe to the channel right now. Every single video here goes deep into one specific machine class at one specific working mine, what it was officially rated for by the factory, what it actually ran in the real dirt, and what the experienced operators knew that made the critical difference between the two. Absolutely no polished trade show content. The documented, gritty operational reality. Understanding the advanced electric drive system of the L-2350 reveals the exact, precise moment when digital algorithms began actively replacing the physical muscle memory of old-school heavy equipment operators. And please leave a comment down below. If you ever operated or maintained one of these massive LeTourneau loaders in the tough coal fields, how did you physically feel the traction control system engaging when you crowded a deeply frozen bank? In a future video, we will closely examine the rival Caterpillar 994 and exactly how its massive traditional mechanical drivetrain fiercely attempted to rival the electric wheel concept. Now back to the bench. How did the veteran operator, totally accustomed to the raw, violent mechanical lunging of older loaders, manually and smoothly balance this massive surge of digital electrical power while completely burying the bucket? LeTourneau cleverly equipped the L-2350 with advanced switched reluctance, or SR, drive motors. Unlike the standard, older DC traction motors heavily used in older haul trucks, SR motors have absolutely no internal commutators or brushes to rapidly wear out. They are simple, solid-state steel rotors driven entirely by rapidly pulsing magnetic fields. This genius design allowed the massive loader to deliver brutal, low-speed torque without catastrophically overheating the hubs during the intense, continuous friction of the digging cycle. But even with the brilliant digital traction control actively managing the wheel slip, the veteran human operator remained the absolute most critical sensor in the entire loop. The onboard computer could easily prevent the tires from spinning, but it absolutely could not read the complex geological composition of the coal face. When the experienced operator drove the massive 53 cubic yard bucket deep into the blasted coal, they relied on a highly specific, deeply ingrained physical feedback loop. As the heavy cutting edge of the bucket struck a deeply frozen toe, a solid, completely unblasted ledge hidden at the bottom of the seam, the immense forward momentum of the 260-ton machine was suddenly and violently arrested. The powerful SR motors instantly surged, fighting aggressively to overcome the physical resistance. The skilled operator actually felt this massive surge as a highly distinct, high-frequency resonance rapidly vibrating right up through the heavy steel deck plate and the seat pedestal itself. Older, clumsy mechanical loaders would violently lurch or completely stall out. The smooth electric LeTourneau simply hummed much louder and pressed much harder. If the operator stubbornly ignored this vibrating warning and foolishly continued to command full throttle against an immovable rock, the immense lifting forces generated by the massive hydraulic cylinders would immediately begin to act directly upon the loader itself. What exactly happened to the heavy physics of the machine when the bucket was firmly pinned, but the operator foolishly engaged the massive lift cylinders to force a violent breakout? The sheer breakout force of the LeTourneau L-2350 was completely staggering. The twin, massive hydraulic lift cylinders exerted immense upward pressure to forcefully tear the 80 tons of coal free from the solid high wall. But basic physics dictates that force must be firmly anchored. When the massive steel bucket was tightly wedged right under an unyielding ledge of frozen coal and the operator applied maximum hydraulic lift, the unyielding rock instantly became the anchor. The tremendous hydraulic force pushed violently backward against the heavy frame of the loader itself. In that violent, terrifying moment of mechanical stall, the massive front axle instantly served as a fulcrum. The immense lifting force aggressively transferred straight through the heavy chassis and physically began to lever the entire rear end of the 260-ton machine completely off the ground. The immense steel counterweight box and the massive rear tires, weighing tens of thousands of pounds, lifted completely silently high into the cold air. The true veteran operator absolutely lived for this specific sensory cue. They absolutely did not wait for flashing dashboard alarms. The exact instant they physically felt the rear suspension unweight and the back of their seat tilt suddenly forward, they immediately, instinctively feathered the hoist joystick to rapidly dump the hydraulic pressure. Dropping a suspended 260-ton machine violently back onto its rear axle would completely shatter the expensive suspension struts and instantly blow out the massive tires. The highly skilled operator had to gently, perfectly ease the massive machine back down to the earth, subtly adjust the bucket angle, and attack the frozen seam from a completely different, safer vector. But once the 80-ton payload was successfully ripped free and the gigantic loader was securely carrying a mountain of coal high in the air, how did the operator safely reverse and turn a machine of this massive scale without completely rolling it over? Reversing a 260-ton machine away from a jagged, dangerous high wall with 80 tons of heavy coal suspended high in mid-air is a terrifying lesson in dynamic equilibrium. The LeTourneau L-2350 achieved its remarkable, surprising maneuverability through an advanced, articulated frame, smoothly pivoting up to 42 degrees in either direction via massive hydraulic steering cylinders. But an articulated machine securely carrying an immense forward payload faces a highly dangerous shift in its physical footprint during a sharp turn. When the massive loader is perfectly straight, the heavy center of gravity is safely positioned right along the longitudinal center line. The exact moment the operator articulates the heavy frame while the bucket is hoisted high to clear a truck bed, the center of gravity rapidly rotates outward, shifting dangerously close to the absolute tipping line of the front tires. A sudden, violent lurch over an unyielding rock or an abrupt, panicky stop could very easily cause the entire 28-foot-tall machine to violently roll right onto its side. The veteran operator managed this extreme risk through a strict, entirely unwritten protocol of mass and momentum. They absolutely never turned the steering joystick while the loaded bucket was at maximum hoist height. Instead, they reversed straight out of the bank in a perfectly straight line, immediately utilizing the high-capacity hydraulic valves to smoothly lower the massive lift arms until the 80-ton payload was suspended just exactly 2 feet safely above the pit floor. This rapidly dropped the dangerous center of gravity straight back down to the ground level. Only when the massive machine was completely stable and low did they carefully articulate the frame to perfectly position for the haul truck approach. But once the machine smoothly pivoted and approached the towering metallic sides of an ultra-class haul truck, how did the loader operator perfectly place 80 tons of heavy material without causing catastrophic structural damage to the truck's expensive suspension? Dumping exactly 80 tons of fragmented material directly into the bed of a 400-ton ultra-class haul truck required incredibly precise spatial judgment. The LeTourneau L-2350 was brilliantly engineered to center-load these giant haulers in exactly 5 fast passes. If the loader operator was too incredibly slow, the entire truck fleet backed up along the haul road, totally destroying the shift economics. If they foolishly dumped the payload off-center, they threw massively disproportionate strain onto the truck's suspension struts, causing severe, rapid tire wear, and major component fatigue. The highly skilled loader operator approached the side of the haul truck with the massive lift arms raised to maximum height, perfectly positioning the 53 cubic yard bucket directly over the absolute center line of the truck bed. They absolutely did not simply dump the material in one sudden violent motion. Dropping 80 tons of solid rock straight from a height of 20 feet would completely shatter the truck's heavy steel bed liners and violently compress the hydraulic suspension struts to the absolute bottom, causing immediate structural cracking. The veteran operator expertly used the bucket tilt cylinders to smoothly feather the heavy load. They tilted the bucket very slowly, allowing the heavy coal to slide out in a beautifully controlled cascade, perfectly absorbing the kinetic impact within the truck bed itself. This highly precise action demanded intense focus, perfectly balancing the engine speed to maintain solid hydraulic pressure while ensuring the loader's front tires absolutely did not slide against the truck's massive steel wheels. They targeted the absolute center line, expertly spreading the material perfectly evenly. But keeping this intense, relentless production pace alive required aggressively protecting the most expensive, highly vulnerable component of the entire machine. What did it actually cost the mine to keep the loader rolling on the absolute largest rubber tires in the world, and how did engineers successfully protect them from the razor-sharp edges of the frozen pit floor? The LeTourneau L-2350 rolled on the absolute largest rubber tires in the world in the year 2000. Proudly manufactured by Firestone, the massive 70-70-57 tires measured well over 12 feet in diameter and a massive 4 feet in width. A single tire cost the mine upwards of exactly $60,000. With 4 massive tires anchoring the 260-ton machine, the rubber represented a staggering $250,000 capital investment that was constantly exposed to the razor-sharp fragments of the unforgiving pit floor. If an operator foolishly allowed the front wheels to slip or slide while heavily crowding a hard sandstone ledge, the highly abrasive rock would completely cut through the thick plies in seconds, ruining the incredibly expensive tire instantly. To highly protect this immense financial liability, brilliant mine engineers absolutely did not rely on the traction control computer alone. They installed massive, heavy-duty steel tire protection chains. These incredibly heavy tire chains securely wrapped the entire tread area in a highly dense mesh of specially hardened steel links. The heavy chains successfully shielded the vulnerable rubber from catastrophic rock cuts, but they forcefully introduced an entirely new massive mechanical variable into the complex engineering equation. A full set of 4 heavy protection chains added well over 30 tons of sheer dead weight to the vehicle. This immense, constant rotating mass placed a severe, absolutely continuous mechanical load directly onto the independent electric wheel motors. How did the brilliant solid-state switched reluctance motors handle this sudden, massive increase in unsprung dead weight when the brutal winter blizzards struck the Powder River Basin and ambient temperatures dropped to an incredible -40? The solid-state switched reluctance motors of the LeTourneau L-2350 possessed a highly distinct advantage over traditional mechanical drivetrains in extremely harsh environments. When the brutal, sub-zero Wyoming blizzards dropped the pit temperature to -40, traditional mechanical loaders suffered immediate, catastrophic component failures. The hydraulic fluid completely gelled, the torque converter seals cracked wide open, and the heavy steel drive shafts became incredibly brittle, frequently snapping violently under sudden torque loads. The L-2350's advanced electrical architecture absolutely thrived in the bitter cold. Because the raw power was smoothly delivered via thick copper cables rather than heavy spinning shafts, there were absolutely no universal joints to permanently freeze or heavy differentials to shatter into pieces. The SR motors achieved absolute maximum electrical efficiency in the bitter cold, as the significantly reduced temperature massively lowered the electrical resistance within the internal copper stator windings. However, the extreme sub-zero environment introduced a completely different, highly complex engineering challenge: terrifying thermal shock within the sensitive control architecture. When the massive loader transitioned from sitting completely idle between truck arrivals to aggressively drawing full power while crowding the frozen high wall, the sudden rush of hundreds of electrical amperes caused incredibly rapid localized heating within the solid-state insulated gate bipolar transistors, or IGBTs, located securely in the control cabinet. This extreme, rapid thermal expansion and contraction could very easily fracture the highly delicate silicon wafers, disabling the entire drive system instantly. The complex system required a carefully managed internal preheating loop that kept the vital cooling fluid warm even when the massive diesel engine was simply idling. The massive machine had to be securely, electrically insulated from its own incredibly harsh environment. But as the pivotal year 2000 closed, the incredible success of this rubber-tired giant firmly established an entirely new paradigm for surface mining logistics. What did the M85 start and the L-2350 successfully finish in the absolute final generation of 20th century open-pit mining? The legendary unit rig M85 successfully proved in the 1960s that electric wheel motors could absolutely replace mechanical transmissions in heavy haul trucks. The LeTourneau L-2350 perfectly completed that brilliant engineering arc at the turn of the century by firmly proving that solid-state electric drives could easily handle the brutal, zero-speed breakout forces strongly required of a primary face loader. By completely eliminating the heavy mechanical driveline, LeTourneau brilliantly created a machine that could physically match the sheer output of a medium-sized electric rope, shovel, but completely retained the vital mobility to rapidly tram across the pit at 9 miles per hour. This incredible mobility completely changed mine planning forever. A tracked electric shovel took long days to slowly walk to a new bench and strongly required a massive trailing high-voltage cable. The completely self-contained L-2350 could simply drop its bucket and safely drive to a completely new blasting zone on the exact opposite side of the massive Powder River Basin in just a single hour. It was the absolute ultimate expression of diesel-electric flexibility, but this flexibility came with a completely uncompromising maintenance demand. The brilliant digital architecture that made the giant machine so capable also meant that a sudden failure in the traction control software could absolutely not be fixed with a heavy wrench or a hot welding torch. As the American mining industry proudly crossed into the 21st century, what exactly happened to the traditional heavy-duty mechanic when the primary loading tool officially became a massive, rolling supercomputer? The traditional heavy equipment mechanic, proudly armed with a heavy wrench and a simple stethoscope, suddenly found themselves staring completely blankly at permanently sealed control cabinets and rapidly blinking digital diagnostic screens. The LeTourneau L-2350 forcefully forced the tough maintenance bays of the Powder River Basin to transition heavily from traditional mechanical repair to advanced electronic diagnostics. The sheer, hard-earned physical knowledge of the veteran operators expertly feeling the mechanical limits of a machine right through the heavy floorboards began to be slowly superseded by highly automated algorithms that actively prevented the machine from ever actually reaching those absolute limits in the first place. If this video gave you something completely real, subscribe. More heavy machines, more massive mines, more of the gritty operational reality that the slick trade show brochures absolutely never contained. Documenting the incredible L-2350 officially marks the end of the mechanical era and the beginning of the highly advanced digital age in American surface mining. And if you ran one of these massive trucks, proudly worked on one of these shovels, or expertly engineered one of these operations, tell us in the comments. If you actively operated a massive L-2350 in the Powder River Basin, what was the very first diagnostic warning you usually saw before an SR motor aggressively threw a fault code? The very next evolution of massive mining machinery belongs entirely to automation, but the rock-solid foundation was brilliantly built by the diesel-electric pioneers. The absolute most complete operating manual for these incredible machines is completely locked in the heads of the tough people who ran them. Most of it was simply never written down.